Every morning, billions of cups of instant coffee are made around the world, and most people making them have no idea what's actually in the jar. Instant coffee has been around for more than a century, and the basic idea behind it has never changed. You brew coffee, remove the water, and package what's left so someone can add the water back later. But the way that water gets removed, and what gets added along the way, is what separates a flat, bitter spoonful of brown powder from something that genuinely tastes like coffee. These are every type of instant coffee explained. Spray-dried instant coffee. This is what most people picture when they think of instant coffee. A fine brown powder sitting at the bottom of a glass jar, the kind that shows up in office break rooms and hotel nightstands in every country on the planet. It's also the oldest commercial method still in wide use, and the process behind it is surprisingly dramatic. Concentrated coffee extract is pumped to the top of a tall drying tower inside a factory and forced through nozzles that break it into a fine mist. A blast of hot air, somewhere around 180 degrees Celsius, hits those tiny droplets and evaporates the water almost instantly. What falls to the bottom of the tower is a dry, lightweight powder with barely any moisture left. The problem is that all of that heat strips out many of the aromatic compounds that make fresh coffee smell and taste the way it does. That's why spray-dried instant often comes across as flat or slightly bitter compared to a freshly brewed cup. Manufacturers try to compensate by capturing the volatile aromatics early in the production process, storing them cold, and spraying them back onto the finished powder before it goes into packaging. This is the method Nestlé used when it launched Nescafé on April 1, 1938, in Switzerland. A chemist named Max Morgenthaler had spent years trying to develop a soluble coffee that actually tasted decent. The product arrived just in time for World War II, when the United States military declared instant coffee essential to the war effort and bought Nestlé's entire annual output. Soldiers brewed it in foxholes and mess halls across Europe and the Pacific. By the time they came home, millions of them had picked up the habit, and that wartime demand is a big part of why instant coffee became a kitchen staple in the decades that followed. Spray-dried coffee trades flavor for speed and scale, but freeze-dried instant coffee goes in the opposite direction entirely. Freeze-dried instant coffee. This is the method behind the golden brown crystals you see in premium jars, and the process is genuinely fascinating. Concentrated coffee extract is first frozen to around -40 degrees Celsius and broken into small granules. Those frozen chunks are then placed inside a vacuum chamber where something called sublimation takes place. The ice inside the granules turns directly into vapor, skipping the liquid stage entirely, and gets pulled away under low pressure. Because there's almost no heat involved, the delicate aromatic compounds that would normally be destroyed by high temperatures survive the process instead. The result tastes noticeably closer to freshly brewed coffee, and it costs about 2.5 times more than spray-dried because the process is slower, more energy-intensive, and runs in batches rather than continuously. But the origin story is what really stands out. Modern freeze-drying wasn't developed for coffee at all. During World War II, scientists at the National Research Corporation in Massachusetts needed a way to preserve blood plasma and penicillin for battlefield hospitals without refrigeration. They built high vacuum systems that could dry biological materials at extremely low temperatures. After the war, those same engineers started looking for commercial uses. One spin-off became Minute Maid orange juice concentrate. Another became freeze-dried coffee. Nestlé launched Nescafé Gold Blend in Europe in 1965 as one of the first widely available freeze-dried instant coffees, followed by Taster's Choice in the United States a year later. The technology that was saving soldiers' lives was now sitting on kitchen counters next to the sugar bowl, 3-in-1 instant coffee mixes. In much of Asia, the Middle East, and Eastern Europe, the most popular form of instant coffee doesn't come in a jar at all. It comes in a small foil stick that you tear open and pour into hot water. Inside is a pre-mixed combination of instant coffee, sugar, and powdered creamer, and the result is a sweet, milky cup that's ready in seconds with no measuring required. Brands like Nescafé 3-in-1 and Copico dominate this market. They're cheap, completely shelf-stable without refrigeration, and require nothing except a mug and a kettle. In countries where fresh milk isn't always available or affordable, that convenience matters enormously. But here's what surprises most people when they first look at a label. Coffee is the minority ingredient. In a typical Nescafé 3-in-1 stick, the actual instant coffee makes up only about 8% of the contents. The largest single ingredient is sugar, which accounts for roughly half the weight of the packet. The creamer isn't dairy either. It's usually a blend of glucose syrup and hydrogenated palm kernel oil. Kopiko, the Indonesian brand best known for its coffee candy, built a massive business around this format. Created by the Mayora Group in 1982, Kopiko expanded across Southeast Asia and now sells in over 80 countries. It became a global name when it started appearing as product placement in Korean dramas like Vincenzo and Hometown Cha-Cha-Cha, reaching millions of viewers who had never heard of the brand. A single 3-in-1 stick typically contains around 9 grams of sugar and about 50 milligrams of caffeine, roughly half of what you'd get from a standard cup of brewed coffee. Instant espresso powder. This one hides in plain sight. Most people have eaten food made with instant espresso powder without ever knowing it, because its main job isn't making drinks at all. It's a baking ingredient. Espresso powder is made from darkly roasted beans that are brewed into an extremely concentrated shot, then dried and ground to a very fine powder. It's far more intense than regular instant coffee, and bakers reach for it because of one specific trick. A small amount, usually just a teaspoon or two, deepens and intensifies the flavor of chocolate in brownies, cakes, and cookies without making the final product taste like coffee. It works the same way a pinch of salt enhances sweetness. The espresso amplifies what's already there rather than adding its own flavor on top. This technique is common enough that you'll find espresso powder listed in high-end pastry recipes from bakeries and professional kitchens. It shows up in savory cooking too, where a small amount adds a roasted depth to chili sauces and braised meats. You can dissolve it in hot water and drink it, but the flavor is sharper and more bitter than a real espresso pulled through a machine. A true espresso has crema, oils, and body that come from the pressure of the brewing process. Espresso powder dissolved in water gives you the caffeine and the intensity, but none of that texture or richness. If you've ever eaten a really good chocolate dessert and couldn't pinpoint why it tasted so deep and complex, there's a decent chance espresso powder was doing the heavy lifting behind the scenes. Microground instant coffee. For decades, instant coffee and freshly brewed coffee existed in completely separate categories. Then in 2009, Starbucks tried to close the gap between them. Starbucks Via Ready Brew was the result of nearly 20 years of research and development that started under Don Valencia, the founder of the company's R&D division. The idea was simple but difficult to execute. Instead of just dissolving freeze-dried or spray-dried coffee in water, they blended traditional soluble instant coffee with microground roasted coffee. These are real coffee particles ground so fine, roughly 300 microns, that they suspend in the water rather than fully dissolving. Those tiny particles add body, oils, and flavor that regular instant coffee can't deliver on its own. The cup tastes closer to something that actually came out of a coffee machine, with more texture and a fuller mouthfeel. The trade-off is a thin layer of sediment that settles at the bottom because the microgrounds never completely disappear the way soluble instant does. Competitors noticed quickly. JDE launched Millicano in 2011. Nestlé followed with Nescafé Azera in 2012. Both use the same core concept, blending soluble coffee with real microground particles. This technology also opened the door to what some now call the craft instant movement. Small specialty roasters started freeze-drying single-origin beans and adding microgrounds to create sachets that score well on specialty coffee quality scales. Brands like Swift Cup and Voila entered the market promising that instant could finally taste as good as pour-over. Whether it actually gets there is still debated, but the gap between instant and brewed has narrowed more than most people realize. Instant cappuccino mixes. Open a packet of instant cappuccino, pour hot water over it, and a layer of foam appears on top of the cup. It looks like the froth from a steam wand at a cafe. But nothing is being steamed and no air is being forced through milk. So where does the foam come from? The answer is a piece of food engineering that most people never think about. Inside those packets, alongside the instant coffee and sugar, sits a specially designed creamer. Nestlé developed and patented this technology in the 1990s. The creamer particles are made from a matrix of carbohydrates and proteins, and during manufacturing, they are pressurized with nitrogen gas. That gas gets trapped inside the particles in tiny pockets. When hot water hits the powder, the particles dissolve and release all of that trapped nitrogen at once. The gas escapes in a burst of tiny bubbles, creating a foam layer on top of the drink. It's the same basic principle behind a pint of Guinness, where nitrogen produces that smooth, creamy head instead of the large, fizzy bubbles that carbon dioxide would make. Regular powdered creamer doesn't do this. It dissolves normally and produces almost no surface foam at all. The difference comes down to density. Foaming creamers are manufactured to be lightweight and porous, packed with gas pockets, while standard creamers are compact and solid. That foam on your instant cappuccino isn't a happy accident. It's engineered into the product at a molecular level, and the technique has been used across dozens of instant latte and cappuccino products for the past 3 decades. Chicory coffee and coffee substitutes. During every major conflict in the last 200 years, people have had the same problem. They still wanted their morning cup of coffee, but real coffee had become scarce or impossibly expensive, so they turned to whatever they could find. Chicory is a roasted root that, when brewed, looks remarkably similar to coffee and has a smooth, slightly bittersweet flavor with notes of dark chocolate. It contains no caffeine. French households started blending it with coffee during Napoleon's continental blockade in the early 1800s, when imports from the colonies were cut off entirely. The habit stuck, and it eventually traveled to Louisiana with French Acadian settlers, where it became a permanent part of the coffee culture in New Orleans. To this day, chicory coffee is the signature drink at Café du Monde in the French Quarter, served alongside fresh beignets dusted with powdered sugar. Camp coffee, created in Scotland in 1876, took a different approach. It's a bottled liquid essence of chicory, coffee extract, sugar, and water, originally blended for soldiers in the Gordon Highlanders Regiment who needed something portable for the field. Today it's used more as a baking flavoring than a morning drink. Then there's Postum, invented in 1895 by C.W. Post, a vocal opponent of caffeine. Postum contains no coffee at all. It's made entirely from roasted wheat bran, wheat, and molasses. Its sales took off during World War II, when the American government rationed coffee and civilians were limited to about 1 pound every 5 weeks, barely enough for a cup a day. Families stretched their rations with Postum, and drinking it was considered a patriotic act, saving the real supply for troops overseas. Decaf instant coffee, removing caffeine from coffee beans while keeping everything else that makes it taste like coffee, turns out to be surprisingly difficult, and the history of getting it wrong is why decaf earned its bad reputation in the first place. The oldest and cheapest method uses chemical solvents, either methylene chloride or ethyl acetate. Green coffee beans are steamed to open their pores, then rinsed repeatedly with the solvent, which binds to caffeine molecules and pulls them out. The beans are steamed again to remove any remaining traces of the chemical. This strips out about 97% of the caffeine, but it also takes some of the flavor compounds along with it. That flat, slightly hollow taste is what defined decaf for decades. The Swiss water process, commercialized in the late 1980s, works without chemicals entirely. It uses water that has already been saturated with all of coffee's soluble flavor compounds except caffeine. When green beans soak in this solution, only the caffeine diffuses out, because everything else is already in balance. The result removes about 99.9% of the caffeine while preserving far more of the original taste. The most expensive approach uses pressurized carbon dioxide. Under extreme pressure, CO2 behaves like a liquid and selectively dissolves caffeine while leaving the oils and flavor compounds behind. It was developed by a researcher at the Max Planck Institute in Germany and produces the cleanest result. High-end decaf roasters tend to favor this method, and it's why modern decaf, both brewed and instant, no longer has to taste like a compromise. Dalgona coffee. In early 2020, as lockdowns closed cafes across the world, millions of people stuck at home discovered they could make something that looked like a high-end coffee shop drink using just 3 ingredients and a whisk. Dalgona coffee is made by whipping equal parts instant coffee, sugar, and hot water until the mixture transforms into a thick, pale, caramel-colored foam. You spoon that cloud over a glass of cold or hot milk, stir it in, and drink. The visual contrast between the white milk and the dark whipped coffee on top made it irresistible for social media. and it spread across TikTok and Instagram within weeks of its debut. The name came from South Korean actor Jung Il-woo, who tried a hand-whipped coffee in Macau and compared its taste and color to Dalgona, a Korean honeycomb toffee candy, on a TV show in January 2020. The timing was perfect. People were bored at home and looking for something that felt like a small event in the middle of an ordinary day. But the drink itself was much older than the trend. Indian families had been making beaten coffee, called fenti hui, at home for generations. Versions of it existed in Pakistan, Libya, and Greece. The Greek frappé, invented by accident in 1957, when a Nescafé salesman at a trade fair in Thessaloniki couldn't find hot water for his break and shook instant coffee with cold water instead, uses the same basic principle of whipping instant coffee into foam. The science behind Dalgona is worth understanding. Instant coffee contains natural surfactants, the same type of foaming agents that create crema on top of an espresso shot. When you whip a concentrated mixture of instant coffee and water, those compounds trap air and hold it in place. The sugar thickens the liquid and makes the bubbles smaller and slower to pop, the same way sugar stabilizes a meringue. And this only works with instant coffee. Ground coffee won't whip no matter how long you beat it, because it hasn't been brewed and concentrated first, so it doesn't contain enough of those surface active compounds to build a stable foam.